Hello, my name is Melvina Green, and today I'm gonna be presenting or trying to present a 3D model of the MC1R protein with both the normal and the mutated version. Um, and the MCR1 proteins actually normally found in the membrane of the um, melanocytes and its receptor, which is responsible for producing pigment within hair, eyes, and skin color. So its main job is to do pigment. So we are gonna go with the model. I really, for simple one, I actually did just a paper towel, not done paper towel kind of roll cut up with some candy that I kind of got for Valentine's Day that I wasn't really using. And then to show the different structures and everything, I use kind of like straws to represent the different foldings of when protein folds, so the tertiary, secondary structure, and this one's supposed to represent kind of like the complexity of it, and the candy represent the amino acids that is wrapped around. Sorry about the mess. So MCR1 is a G protein couple receptor, which means that it spins the cell membrane 7 times. So the straw represent that, and this also represent the transmembrane helixes. So that's also one thing to remember. So the difference in color, as I stated, represent the amino acids and their structure together. Okay, so for the mutated protein, so for example, since I have all of this wrapped around, let's say we take this one out kind of in the essence of just imagine removing amino acids from there. So removing that from there, so replacing the antigen with this cytosine amino acids. If we remove that, this mutation could cause the receptor to misfold. So this is what we're kind of looking for, but sorry. But if we misfold, we might get something even though similar but quite different with it. So in that case, we could get like a reduced binding signal for the molecule to bind, or a less production, which can represent in like either lighter pigment and darker pigment, or lighter pigment, depending on if it's over produced or lesser produced. So yeah. So for example, when MCR1 is working properly, the signal cell produces like a emolanin. Oh my god, I'm mispronouncing that wrong, which help produce protect skin from UV damage. But in like a mutated one, so we could see that with that we have higher sensitivity to skin to sunlight. So with this kind of candy will represent that. So that's where you see in fair skin people, they either get burned quickly from sunlight, where darker skin tone may not from that. So limitations with this model, of course, that it's not really the size to scale. This model is very complex. Also, to just my material that I use is not realistic in a sense of showing how these membrane and mechanism and these lipid bilayers and all of that will work. So that's also to my folding and everything is not representations of actual how it might occur in the cell. So in conclusion, the protein involved in pigmentation, MC1R and C1R, which involved in pigmentation, um, again affect and alter skin color, hair color, and all of that, which is risky to skin cancer and other form of skin condition. Um, but also to showing how removing one kind of single amino acid or replacing it can cause a much more different in skin tone. So just imagine that it is. So that can have a big impact on individuals and how they're producing melanin.